Okay, we're live. All right. So today I don't have any slides because we're going to jump right into what we're going to talk about, which is the recent Windows local privilege escalation 0-day proof of concept. And I'm going to do a little bit of background on how this came about, what it was, what the discussion was, and some of the drama, but not a lot of it because this is mostly a technical podcast or webcast. So I will talk a little bit about the discussion behind it, and then I will dive into the actual code, and we'll do some demonstrations with the proof of concept, or one of the proof of concepts. And then I will talk about some mitigation strategies, some constraints of the RedSun, specifically the RedSun proof of concept. And then, and we'll talk about some ramifications this might have in the future for Windows security. But I'll jump into where this started. I'm going to need to open up a share screen. Let's see, my Windows VM. Here we go. Picture in picture. All right. So before I jump to the actual GitHub repository, the discussion started when a post was created on this Blogspot website where the original author, going by the name of a couple different names, Chaotic Eclipse, Nightmare Eclipse. They basically had posted a somewhat of a warning to Microsoft that they were not happy with the way MSRC was triaging vulnerability research and whatnot. This one was kind of just lore. And then the first one was actually March 26th. And then the first POC drop was April 2nd. This was a couple weeks ago at this point. And they dropped a link to a GitHub repository where they basically are saying this is a 0-day. And, I'm not going to go into specifically like what this person is saying because I don't think it's very relevant to the sorry, I just realized I'm not signed in. It might not let me view the code, which is annoying. Okay, I'll just show it on here. So sorry about that. Back to the timeline here. So we first got Blue Hammer, which was this exploit here. And it basically was a pretty long POC, a lot of code in the POC, and it did demonstrate that they could pop a system shell from a low privilege user with it, but it relied on a bunch of different things being true, one being there needed to be a defender signature queued for update, which is a pretty strict constraint for a privilege escalation vulnerability. So it was good, but it wasn't super weaponizable. And so then the Microsoft created a CVE for this. They assigned it a CVE, and then they released a patch supposedly for it in Tuesday. I think it was Tuesday, April 14th. And the security researcher came back with another post where they publicly disclosed RedSun in their blog post. basically RedSun is a similar vulnerability, if not the same underlying vulnerability. And they posted the POC here. So this one is a lot more weaponizable because it's, well, one, it's a lot fewer lines of code, and it relies on a trigger that the person running it actually controls. There's a couple constraints with it. We can talk about those in a little bit. But I should also mention there was one other vulnerability or POC that the person reported on, which was called undefend. Let's see, it's over here. Yeah, so this one's a different kind of vulnerability, or at least the POC is a little different. It's not a local privilege escalation, but it's used to like kill defenders telemetry. But in this webcast, we're going to focus on RedSun because it is a local privilege escalation vulnerability to get system level access from a low privilege user breaking one of the Windows security boundaries. So we can go through the code. First, I want to hop over to my VM where I actually have a little graphic. So I have a graphic of the, where are we at? So I have a little graphic of the way RedSun works. I'll give you like high level overview, and then we are going to go look at the actual POC. So these were all publicly disclosed on GitHub, and they have like over 2,000 stars at this point. But interestingly, not taken down by Microsoft or, GitHub. Microsoft owns GitHub. But here's like a high level overview. So the exploit, so it's a privilege escalation, assuming that you already have access to a Windows host as like a lower level user. And it works by exploiting the way Windows Defender rewrites a file during its triage process of if it flags a file. So if it flags a file for being malicious, it will at a certain point rewrite that file to disk, and it basically exploits a time of use window in which the attacker can put a lock on that file and then replace the file with a different malicious file. And when it's rewritten by Defender, Defender can write to any directory because it's running as system. And so during that window, an attacker can replace it with a different file. In this case, the exploit rewrites itself. So it copies its own executable file to that location, re-executes itself by spawning a different service called tiering engine service, which we're going to talk about in a little bit. In the future, people may look into alternate paths to execute that portion of this, because that's not the underlying vulnerability. And it basically copies itself to that new writable directory, and then it executes itself with system level privileges and walks down a different code path. So all of the three POCs kind of take advantage of the same issue in Defender, where it rewrites with those permissions, and then takes advantage of the ability to swap out the file with a symlink file before Defender actually uses and deletes that file. I have the original POC pulled up, except I added some of my own comments just to walk through it easier. But I think the original, let me see, I think it's like, yeah, it's like less than 800 lines of code because there's a lot of spaces, but my one VM's shutting down. So we can start walking through some of the code here, and then we can reference back to the graphic if we need to. So we open up with this main function, right? It creates a named pipe. I renamed some of these pipes here just because I was messing with different signatures that Defender has created since this dropped last Wednesday. So it creates this named pipe mainly for inner process communication. So to communicate when it copies itself later on, it can communicate with that other process. And then we come down here and we make a format string for a temporary file. They use this RS RedSun like prefix, and this will be in the temp, so like local app data temp folder, and it writes a file called tiering engine service, which is notably important because that's like what it uses later on to spawn that process. And then we're going to kick off a new thread, which monitors shadow copies of files. So it uses the volume shadow copy service and monitors for new files in Windows shadow copies. So that's important because it's going to create a file that gets flagged on purpose. And then when it gets flagged by Defender, it's going to create a shadow copy of that file. We can walk through. It's basically getting a list of shadow copies, putting it into a structure, and then scanning for new copies, new files that are popping up in that directory. And this all runs in a separate thread than the main thread. And then it alerts the main thread using, let's see, down here, using wake by address on all, sending a event to the main thread when it finds that a new file is in the shadow copies. We'll jump back to here. Okay, so that thread gets kicked off. It's running. Then we create a new file. This file will be that iCar file. So part of this vulnerability is that it relies on actually triggering iCar, like a Defender signature on iCar. It could be any like Defender signature, but in this case they use iCar because it's a simple string you can reliably trigger Defender with. So it will create an alert. It's just not an alert for what this vulnerability is doing. Those signatures are being made, but so then we create that file. We open it with the file execute flag, which forces Defender to scan it and trigger on the iCar file. At this point, Defender will start making those shadow copies, or one shadow copy of the file, and our other thread will notify this main thread. We wait for that shadow copy to be created and send a signal to the main thread. We mark that file for deletion. We register the temporary directory as a cloud file sync root, which is like a special type of directory. And we set a placeholder, a cloud placeholder on this temporary file we created called tiering engine. Okay. We register the directory here as cloud files sync root. And basically this just gets treated differently by Defender when we go to overwrite. And then we create that cloud placeholder on that file in the temporary directory. Jump back. Okay. Let me see. One of the other things I wanted to touch on was the oplocks. Let's see. Might be, let me see. No, it's not in that function. Okay, here. All right, so now we rename the that temporary directory with the temp suffix, and then we recreate the original path of that tiering engine service in that temp path as an empty file, right? So, and then we request an oplock on that file, which is like opportunistic lock. It's like a Windows feature that allows you to get notified when a different process is trying to access a file with like conflicting rights. So in this case, when Defender goes to delete that file, we'll get a notification from this device IO control. And they use the batch oplock flag. We rename the icar file tiering engine service with .temp2 suffix. And then we mark it for deletion. And then this is when there's a gap in time of check, time of use, where we can replace that temp file with, or that directory, or the file, I guess, with a different file that's a symlink file that points to Windows System 32, which is typically not writable by a low privilege user, but in this case, we'll have a handle to that file, and Defender will use the original access control list for the file so that the original author of the file can still edit it with full privileges. So we convert this to a mount point, which references C Windows System 32, which, like I said, is not typically writable. Reparse point, which is basically like symlink. And then we wait for Defender to rewrite that file. And we, in a big loop, we check if that file is now writable. As soon as Defender rewrites the file, it will be writable because it uses those original access control lists from the icar file that we originally wrote. And so tiering engine service will now become writable in Windows System 32. That becomes a problem because we can replace it with any arbitrary file. In this case, we overwrite our own executable. We copy ourselves, so we get a module handle to the current module, and then we resolve the current executable name. And then which will be like RedSun or whatever, in this case, RedSun modify.exe. And then we will replace tiering engine service 32 in Windows System 32 with our own executable. And we will kick off the COM service launch tier management engine, which basically invokes this COM object and launches tiering engine service.exe from Windows System 32, which is just a way to initiate that executable in this case. One of the things Defender has been flagging on is this GUID, because it is a hard-coded string and it's a important part of this POC that's not easily changeable, although there might be other paths to execute in the future. But the main vulnerability is in that Defender rewrites the originally flagged file with the same access control list that it was originally created with, meaning that the user can have full control over that rewritten file. And then basically when this is rewritten itself to tiering engine service 32, we launch into this code path is running as local system, which checks here. And then we check ourselves against Windows local system ID, system SID. And if it is, then it's achieved local system. And we launch conhost.exe with this impersonated token for the logon session. So I know that's a lot. Took me like a long time to work over it and like understand each section. But at the end of the day, it's like a time of use, time of check, insecure file rewrite with original access control list for a file that was originally modifiable by the low privilege user. So my Windows 11 VM shut off. Let me turn it back on. And so Windows has implemented some detections for this, not patches, but detections. So the original binary is going to get flagged right away as a RedSun exploit. I've tried to implement some different features or edit some strings in it that will get rid of the signatures, but it's still getting flagged at this time. But I did take a snapshot of my VM before that to make sure I could show it. So we are on this with no internet so that we don't get Defender signature updates, so I can show what it was like before this they started implementing some of the detection signatures. So I'm going to copy this POC over. Let's switch this. So open up terminal. And I just want to show real quick that I am not a local administrator. So we have low priv and Mike. Low priv is just a user. Mike is a administrator. So if I try to open like terminal, run as administrator, it'll prompt me for password for Mike, which we don't have in this case. And if I try to write to system32, it should deny that. So there we go. We are a low privilege user. We'll run this sample modified. As soon as we hit enter, it's going to spawn the icar file. And then it relies on Defender actively triaging that file. So I'll speed it up with start action. Now we should be monitoring for shadow files and then performing the rest of the exploit. Sometimes takes a second. And so in this case, it still works. We get this administrator shell. We can do who am I all and see that it spawns a shell as system with all of the privileges. So proof again, I think if we do this, we might be able to, I don't know if this works in regular CMD. Okay. All right, so there we go. We did what we couldn't have done earlier to show that we are system. Now, they do have some detections, like I said. Can jump into some further snapshots. This one should be fully up to date, although they have not patched the vulnerability yet. So we can show that by setting some exclusions and then basically still doing the exploit, but setting some exclusions so that we can avoid some of the detections just to show that it still does work. We'll give a second for our VM to restore. I'm just restoring from a snapshot, so it's going to take like 30 seconds. Okay. We'll do check for updates. This one, I do have the internet enabled. Give this a second, and same thing with no administrator. So prompts for password. I just want this to come back, show that we are fully up to date. Okay, so up to date. Let Defender look for some updates. And I set some exclusions. So I set some exclusions because one of the, I will enter the password for this one so I can show it. So I set the exclusion to Windows System 32 and temp because one of the detections, well, there's a bunch of detections in the original binary. I changed some things, but they have some detections now that I haven't gotten enough time to play with and try to get around. And then One of the other things is the right to tiering engine service in system 32. So that's getting flagged. So I just set that folder to an exclusion. But those have nothing to do with the actual vulnerability. So if I run this, it should still work, but let's see. So I need this to start scanning. And it still works. So this is the latest Windows 11 version, and they haven't patched it yet. So I'm sure they're working on like a deeper underlying patch for all three of the issues. But yeah, so I think this will be used by threat actors, probably create some sort of different post-exploitation tooling. There are a couple constraints with this vulnerability. So one major one being it requires Defender is enabled and not disabled by preferring some other EDR product, which a lot of EDR products disable Defender. So like it's like pretty common thing. So this would not work as far as I know if you had some other EDR product disabling Defender and using that for your main EDR or main AV. It does create an ICAR detection, so that's like a pretty dead giveaway because that's pretty rare in looks like it didn't actually pop that time, which is interesting. So it is finicky a little bit. But yeah, so it creates that ICAR detection, which is a dead giveaway for the SOC probably. Plus, there's not a lot of post-exploitation tooling that's been created yet using this. If it is patched, I assume that it won't be used as much anymore, obviously. But until then, Huntress did come out with some post-exploit or some real threat actor using it in post-exploitation. They were using like the original POC, which got flagged like right away. So not too surprising there. They might have just been trying it out. The other major thing is that this tiering service, so it's pretty easily detectable if you're writing to System 32 with a file tiering service that's not actual tiering service. So that's a really strong point of detection. There was some talk, let's see if this link will work, on Twitter. I already have it. About different COM objects that could be used to trigger this. This person talking about print filter pipeline service, which I tried to get this one working, but I couldn't. So I don't know if it does work, but that's an alternate one. Even when I did try to get this one working, Defender flagged overwriting that binary in System 32. So there are detections for Defender, which is kind of ironic because they originally said it was like not an issue. They weren't going to pay for the bug bounty. Huntress has a really good breakdown of all three of these. So they go into depth about all three of the issues. Blue Hammer, RedSun, and Undefend. And then they talk about the real world activity they saw, which was using like the default precompiled binaries, which, you know, obviously not like super advanced threat actors using it like that. Let's see what else I have. We can show some of the Windows Defender signatures. So if I copy this outside of that directory, we'll get this. Defender RedSun, so they have some detections for either some code or basically some bytes in the binary that I'm not 100% sure. It's probably multiple things at this point, to be honest. And there was another one, but let's see. There was another separate detection, separate from this code here. So yeah, they basically have some detections in place for the unmodified binary, but if people do find a way around those bad bytes, then it's still fair game to use this in the wild as of right now, April 24th, 2026. So yeah, it's going to be interesting to see. I'm assuming they're going to come out with some patch in the next Patch Tuesday that address these issues. If not the next one, I don't know at this point. But it's been shown at this point it is a legit vulnerability that allows you to escalate privileges to system from a low privilege user. I mean, I don't think there's going to be any question about it at this point. I think that's most of the stuff I wanted to show. I could jump into maybe some other thing I was playing with. Jump to this snapshot. So one of the other parts of this vulnerability is that right here is where it actually does the file write, the privileged file write to tiering engine. So this theoretically could be anything. Make this bigger. So I was playing around with doing some mythic payloads here. I don't know if I have it on hand. Let me see. If I jump over, I'm getting movie mode on the VM. So let me open up my Mythic server. $20. Let me do it in the dev VM. Seven, 4, 4, 3. So I was playing around a bit with this. Delete these old ones. So this is just a Mythic C2 server configured with one of my C2 agents, Xenon, that I wrote. It's basically for Windows, kind of like a Cold Strike alternative. But the point is, if we overwrite this path with a different path that's on the file system. So like instead of copying ourselves, right? So like the RedSun exploit itself, we theoretically could just copy in a different path that is like a beacon or something like that and run that one as system, which is why this is like a important vulnerability, because you could escalate from initial foothold to system privileges on the host. Let me run and compile that. And then transfer it. Let's see if it still works. Oh, it's getting flagged. Maybe I'll throw it in temp so that it doesn't get flagged with that for demonstration purposes. Okay, and then I need to make sure, what is this? I need to make sure that that Xenon path exists. And then let's see if I can run it. I got to go into temp. Where's the ICAR detection? This might be the Xenon payload getting detected. Yeah. Let me see. How can I show this? You know what? I'll change the path just so like this isn't getting detected, so we can actually show just. I just want to show spawning a different process. That's the point. So transfer this new binary over to temp, not there. And then I'll put that Xenon one in there. Let's see. So there's the ICAR, maybe. It might have an issue. I've never tried it with multiple shadow files going at once. So there might be, I don't know, something that goes wrong there. And we're not actually going to see the Xenon payload go, I don't think. It'll be running under tiering service. Windows is freaking out at this point. It's saying restart now, restart now. Let me see. Let's try it one more time. Yeah, I wonder if it's an issue where if more files are being triaged at the same time, it finds the wrong file. Definitely possible. Oh, let me see. I think it might have detected. Yeah, so I think it detected Xenon when it got overwritten as tiering engine service, which is fine, but it doesn't really show what I wanted to show. Whereas like if it executes, it's now running the beacon as system. But all right, might just have to trust me on that one. We're getting close to the end of this webcast. I don't really have a whole lot more other than, yeah, it should be interesting to see what happens with the patching when a patch is released and how long it takes, because at this point, aside from Windows Defender detections, the vulnerability is still exists in latest Microsoft Windows 11. So it should be interesting to see. I think that's everything I have. But yeah, it was kind of a tiring one, but it was interesting to go through this POC and see how it works, and see what happens in the future to if things are created adjacent to this issue, or if Windows actually implements like a long-term fix. But I guess we'll see. I think that is it for this webcast and this stream. I'm going to log off at this time. So thanks for joining. Stay safe.